Good to start, Sarah?
Yeah, absolutely. Welcome everybody. Thanks for coming along to the Make It Smart Hub Digital Tools webinar. My name's Sarah Buchanan. I'm the Impact Manager for Retrofit and I've just joined the project. It's part of the Advanced Manufacturing Challenge Fund, funded through European funding and supported by HIE, HIE and Inverness College UHI. Welcome to our speakers. We've got a fantastic programme for the webinar. Matt Stevenson from Ecosystems, Paul Redmond from SRO Solutions, Gordon Mitchell from Key Facilities, and Stuart Little from IRT Surveys. And I'll do a wee intro as we introduce each speaker. A bit of housekeeping, of course, with all of these webinars. The session will be recorded and available to view on YouTube on the channel next week. If you would like to ask a question or leave a comment, please do. Your engagement is really important to us. And we'd love to have a question and answer session at the end of all the speakers. Your feedback is extremely valuable, so even if we don't get to answer your questions or your comments, we will come back to you with the answers if we can. The Make It Smart Hub project has been set up to essentially help SMEs in the Highlands and Islands region to access digital technology, modernise, use equipment, make investment decisions. We had budget in the project to procure equipment, which we're going to see some of today. Unfortunately, we don't have the heat meter yet due to logistical problems. It will be here mid-March. However, if your company is interested in seeing a trial of the heat meter, I can organise that for you. Just get in touch with me. And we'll be hearing from all of our speakers about digital technology, how it can transform your business and the industry. And of course, we'll be seeing a video of some of the equipment that we have as part of the project. We do have budget left for equipment to buy. So if you have ideas for your business that will help your business create new products, new services, get in touch and we can have a chat. So without further ado, I think I'll move on to the first video. I'll just hand over to Danielle and she'll play it for us.
The Leica BLK360 is a compact imaging laser scanner that uses a 360 laser distance meter and high-definition panoramic imaging to create a 3D point cloud of the space around it. LiDAR technology captures 360,000 points per second. 3 spherical panoramic HDR cameras with a thermal imaging camera deliver 3D point clouds with millimeter accuracy in minutes. A LiDAR scanner creates an accurate and detailed digital record of real-world space and objects. Combining this with BIM models and data, an accurate digital twin can be developed. "3D scans can be used to keep a record of in-progress work, mapping and overlaying changes as a job develops. The BLK360 is small, compact and easy to deploy on-site or in restricted spaces. Laser scanning improves quality and accuracy of site information. Scanning is also fast, efficient and cheaper than other forms of project mapping. The Craftbot Flow IDEX XL printer has one of the largest print volumes of its kind. Large-scale FDM printing allows quick and accurate prototyping of industrial-scale objects. IDEX technology allows reliable dual extrusion, running 2 independent print heads. 2 different materials can be preloaded to allow multi-property objects, bicolor items, or objects with PVA support. With this large volume printer, you can not only print large objects, but can also duplicate your performance by printing 2 objects at the same time, in mirror or parallel mode. Available through the Make It Smart Hub, SMEs can access this technology to enhance their current R&D processes, test new opportunities, or create custom unique objects at point of need. This equipment was procured for and made available through the Make It Smart Hub for SMEs in the Highlands and Islands.
So I hope you enjoyed that quick demonstration of the equipment that we have currently that we would love to demo to you face to face. We also have obviously the heat meter coming in as well, and we will make that video available. Don't know for anybody else, it was a wee bit kind of glitchy for me, but we can send out the video links so that you can have those videos to hand. I'd love to introduce our first speaker, Matt Stevenson from Ecosystems. He's the designer and founder of Ecosystems Technologies and is dedicated to digital transformation in the construction industry, applied innovation in the timber technology industry, and the democratization of sustainable, healthy building solutions. Delighted to have Matt here to share his journey with you. Thanks, Matt.
Brilliant. Thank you, Sarah. Bearing in mind time, I'm going to take us on a bit of a whistle-stop tour of stuff. We've done a lot of work with augmented and virtual reality and different digital sort of approaches to things. Digital is from end to end in the processes that we do, from design through manufacture to post-occupancy. But I'm going to focus for the purposes of this presentation on just the live work that we're engaged with at the moment, and a couple of examples of that, and then some of the dissemination work. So if folk were had the opportunity to visit the Innovation Factory during COP, they would have hopefully come via Central Station, seen the homegrown mass timber figure that we produced there for the Beacon of Hope. But at the factory here, you would have seen the Synergy demonstrator, which I'm sat within at the moment doing this presentation. You would have seen the Gen Zero schools prototype. Again, all of this is homegrown mass timber, the first rollout of live homegrown mass timber projects. This is a demonstrator for UK government's Department for Education for schools which hopefully will be the way that we build schools in the future, using all biogenic and healthy materials. You'd have seen the off-grid travel hideaway cabin that we produced, and you would have seen the near home retrofit kit of parts project which we've done, which I'll focus on in a bit more detail here. So this is a project. Phase one was supported by funding from Scottish Government via Transport Scotland, provided to CSIC, who we collaborated with as lead designer on development of a near to home kit of parts solution for retrofit and or new build office hub type developments. We leveraged componentry which we'd established for earlier projects like this Synergy demonstrator, the glue laminated timber portal, and we evolved that as a kit of parts solution. Now what I'm going to do, and apologies, is I'm going to jump around a little bit to show you a bit more of that. So in the evolution, following on from that phase one work, we then produced a design toolkit, so a kit of parts that allows us to import data from 3D model, in this instance SketchUp, so we can import the footprint of an existing building, and then we have the design toolkit has a set of componentry kit of parts that automatically self-generates elements to populate that footprint of building. We can then adjust and modify that to get the preferred configuration and grid for the project. We can then go through and optimize the layout and work out what the optimum configuration is for office breakout space, and so on and so forth. All of this componentry is predetermined, so nothing's designed as new elements for this. It's all stuff which you're choosing from a predetermined palette of options, and you can go in within that and choose to select and alter the wall finishes. Here we're applying a nail laminated timber wall rather than a plasterboard wall, for example. We're adding color. We're changing out the color across the whole breadth of the project, and and really going through and just configure it and optimize it to best meet the needs of the project. What this also generates is the quantities, the carbon impact. We can bake into this all the life cycle data and so on and so forth, and then the resulting model can be dropped back into the original 3D software and adjusted further if required, and become part of that overall overarching model. So that's the design toolkit. Now, what that does is it leverages some very effective work that's been done by Andrew Livingston, Dr. Andrew Livingston from Napier. And I'll just zoom through, sorry, wrong video, zoom through here. What Andrew was able to do was take all the componentry and create the mathematics that sit behind the structural analysis, so that we can have different layups of configurations of lamella, different sizes of portal and componentry. And what it's then able to do is input all the project criteria, whether it's the height of a bay, the span of the bay, number of bays, all this sort of key project information. I'm zooming through, so apologies if it starts getting a bit sea-sickening, but drop on this bit, we're then able to sort of plot it geographically and work out what the wind speeds and wind loads are. And when you enter that in, you can have an internal arrangement or an external, and it'll adjust for the wind loadings accordingly. And we can then just keep going through and stretching the parameters of what can be done. We'll get to a point, so that's where it's showing the different wind speeds, and it'll input the criteria of where it is, how close to the coast, how high, and stuff like that. So and that all then inputs and continuously updates as a configurator, a structural configurator. We will reach points where we exceed the parameters of the system as it stands, and then we can dial back and to find a point where it works. And that may require us to reduce the span or increase the number of bays to get the right result. I'll dash through that there, because yeah, that's all of that computational mathematics is then the back end to the configurator I showed before. Now this toolkit that we've produced, we've already started to deploy that onto projects. So here are some screenshots taken from, we were asked to design a solution for a client who needed a 150 square meter unit. We were able to very quickly run through that and export very quick results, and that project can move through the gears really responsibly. Conscious of time, we've delivered a project recently, first rollout of a homegrown mass timber project for Fettes College. You can see it here, getting manufactured in our factory in Invergordon. All of the mass timber componentry was manufactured down here at Blantyre at the Innovation Factory, delivered to site. Now this project, I'll zoom forward because interestingly this landed onto piers, and through the course of delivering the project, we found extra services on the site and all manner of structural challenges that were leveraged into the project, which meant that we had to keep adjusting the configuration and the design. Here's the finished project, but we had to be very agile in responding to changing parameters to design to. Now, we've got a very live process going on at the moment where all of the information that you would have had a glimpse of in Dr. Andrew Livingston's previous presentation that I flipped through is now feeding into a design toolkit which does all the structural analysis, and it does it, creates a mesh for the entire structure. It understands, or it has inputted all of the characteristics of our homegrown structural products. That's cross-laminated, glue-laminated, nail-laminated, and glue-laminated timber portals. All of that information resides within that software, and it means that what we can do now is create very optimized solutions that respond to the project characteristics. But what vitally it means is that if we need to change characteristics, change parameters, we can do that in a very live fashion to optimize, either because it's essential to do that or because we see an opportunity to do so. Now, often in a project timeline, that we've been negated from doing that because the design time would be prohibitive, either in the time it would take or the cost of doing that. Now, there's a whole other set of BIM tools that Andrew's evolved here, so that we can be parametric in our approach to that, but I haven't got time to delve into that. What I would really like to do is just give you a sneak preview of some of the other work that we're doing in terms of the dissemination. Dissemination is crucial to us and the work that we're doing. Here you can see we took a scan of the factory floor at CSIC, the LiDAR scan that you saw Matt showcasing before. We've now got actually a full artifact of the presentation, but this is an export from our 3D model. What we have is the ability to interrogate and go and understand projects, to have hotspots, to be able to delve into this in more and more detail. Excuse my phone. And it would be a resource that allows people to have an active interest in the projects that we're delivering. I'm going to nip out of that and give you an idea of how that could look from an augmented reality and a virtual reality perspective. So this is work that's been done by another collaborator. So the previous work was Digital Noughts. This is Edify. They've got a digital education platform. We can actually drop live content from projects into this as a resource and allow people to be able to interrogate. In the past, we would have had to create animations such as this one. Now we can actually delve into and see the projects, all of the rich content that comes from the delivery of one of our projects. So here you can see very live cross sections of a build. If I zoom forward again without making everyone too sick, we can go into a virtual environment. So we're going to establish a virtual knowledge library where people can go in and really interrogate the data, the content that sits behind the project. So here, if somebody wants to see and analyze the structural reporting and calculations that went into the creation of a project, they can see it here. The reports on the left-hand side, the physical prototyping is in a video on the right-hand side. We can delve further in and see that cross-section of a building. We can align that with a drawing and understand very tangibly what that means. I think I'm running over time, so I'm going to zoom forwards further. We can mark it up, we can use it as a live tool, and we can actually do a walkthrough of the process of manufacture and really sort of give visibility and clarity and remove all obstacles to understanding the manufacturing process. We want to make this a tool and a repository of information that captures all of the rich data that exists from the marketplace, from the industry, all of the work that's been delivered over time by all the different stakeholders who we collaborate with can be captured within this and made available for students, for the next generation coming through, to really understand and facilitate them specifying mass timber, biogenic based materials, and so on and so forth. I'm going to come out of that and I'm going to stop my presentation because I've gone over time. So thanks very much. I hope that wasn't too much of a whistle stop, but great to present things. Thank you.
Hi, sorry, slight technical hitch there. Thanks, Matt, that was amazing. So good to see sustainable materials, digital design, augmented reality coming together. If you want to find out more about the technology that you've just seen there, obviously you'll have a recording, but please get in touch. We'd love to share knowledge on the project. I'm just going to introduce our next couple of speakers. We're going to have a shared presentation with Gordon Mitchell, who is an FM digital solution architect and full lifecycle transformation lead for Key Facilities Management International. He's very involved in the ISO technical committees. And Paul Redford is an independent consultant working for RSO Solutions and they focus on helping the built environment clients identify how they can achieve their outcomes through applied technology and services. So looking forward to their presentation. Thanks, guys.
Hi, both. Can you hear me okay? Shall I start?
Yeah.
Can you get their presentation up there? So it's Paul Redmond from SRO Solutions, working as part of the innovation team, looking at whole asset lifecycle and how we use that technology. And that's me on the left. When I used to, it looks like I work in a McDonald's drive-through. It still do, look. And that's Gordon on the right. So we may as well get on to the next slide, Gordon. I'll be presenting 5 minutes and then hand it over to Gordon halfway through. So some of the concerns and opportunities, as it says there, in terms of the built environment, there is a lack of, my feeling, talking to lots of clients up down the country and globally, a lack of understanding of what smart buildings is all about within the AC and the wider built environment. It's more than just bricks and mortar. Smart buildings is a different skill set, and hopefully some of the slides will bring that to life. Another concern is that we come across a lot is lots of these systems that are used across the whole asset lifecycle within the built environment are very, very siloed. There's some great solutions, but there's a lack of solutions that actually talk to each other, giving the clients the necessary data, the joined upness that's needed for golden thread, for example, and therefore we are promoting and pushing for open interoperable through an ecosystem of partners. So we recognize we can't do it on our own, and we need a bunch of partners to support us. I think there is more and more of a recognition that everything needs to be data driven in terms of providing insights and decision making. But I think the lack of understanding is how the client can get hold of that data. And again, hopefully this presentation will bring that to life a bit. Next one, please, Gordon. So as you see there, classic design, build, handover, operate phase. What we see a lot of is probably the AC construction consultants and architects, unfortunately, too focused on design to handover and not so much on the design to operate all the way through to design to commission. So that is a problem today. And we're very much, of course, looking at this whole thing through an operational lens. And so as we look down the path, down the pipe, we're actually saying, you know, you need to think of your business outcomes. You need to think of that operational phase, because basically that's where 80% of total cost of ownership is found, and most of the carbon footprint is found as well in the operational phase. And of course, you know, whether it be governments or whether it be soft landings, whether it be NEC4, NEC3 contracts, you know, clients and AC market are being pushed to think about whole asset life cycle. That's one key message. The other is the importance of static and active data. So when I talk about static data, we've seen some of that from Matt in the previous slide. It's dimensions of a room, it's the products that are being used, the manufacturer part number. That's all well and good, that's absolutely necessary, but we need to bleed in the active data coming from IoT sensing devices and BMS solutions. So what we need to do is actually, and what we are promoting, is pulling all those different data sources and ensuring that they are joined up throughout that whole asset lifecycle. So the box is down there in black. We need to take the Revit model, we need to push that into a common data environment that needs to bleed into an asset management environment that we can feed in IoT and BMS data, cloud of choice, digital twins, etc. All those parts in black there, they can't be siloed. They need to be joined up to ensure that golden thread. Why? As it says underneath, ensure open interoperable systems to facilitate the creation and extraction and manipulation of data to achieve business outcomes. That's probably the most important sentence in the slide deck. Next one, please, Gordon. When we come across clients, we see a lot of what you see on the left-hand side there, lots of different systems that don't talk to each other, too many disjointed, and therefore, you know, you can't, it just creates silos. What we want to get to is the piece in the middle through our ecosystem of partners. We've got fewer pieces of the puzzle, fewer systems, but it's totally integrated across whole asset lifecycle. What we're avoiding is trying to paint everything a single color. I won't mention names, but there are some big organizations out there that will tell you that they can cover whole asset lifecycle requirements, but the problem is their solutions are more often than not proprietary, closed, that walled garden, locking the customer in. What we're seeing is clients and government, as it says down in the red there, they're pushing for key principles of we need the AEC market needs to go for that open, modular, best-in-class, value for money type solution. What you're seeing in the center there. Otherwise, you know, they're not being considered. So we're being forced to change from government, and we're going to see more and more of those key principles being imposed by the client as well. Next one, please, Gordon. Well, as I said up front, we recognize we can't do this on our own. We're good at some of that end-to-end piece. So we're good at asset management. That's what SRO solutions are good at. But this needs to be about collaboration. So we brought together, there's some names on there, but we brought together, Gordon, I think it's about 15 or 20 partners that are willing to collaborate, that are like-minded, thinking open, interoperable, thinking about that golden thread of data to ensure those business outcomes for the end client. So whatever I talk about, whatever I've spoken about today, it's not just SRO solutions, it's definitely an ecosystem partner offering that we've brought together. Next one, please, Gordon. So we're not just talking about it, we can actually do it. We've got a sandpit we can show of how we've brought, I think it's about 9 or 10 of the partners together as part of that interoperable life cycle end-to-end systems where we've got Revit models talking to the CDE using COBie files from the IFC. I don't want to get too technical about it all, but when you see the video, it's for, I'll say it's for dummies, and so anybody should grasp what we're trying to achieve and the importance of data and the importance of data to drive business outcomes. We mentioned digital twin, we've mentioned analytics as well in the previous deck. That's just driven by data. And so if we can get our hands on the data, collaboratively get our hands on that data using open interoperable systems, of course, that data is going to help us with our digital twin and with our analytics. Gordon, over to you.
Thanks, Paul. Hi, everyone. Glad to be here. So really flowing, I guess, from what you heard from Matt in that construction considerations through to Paul and assets and the operational phase technology, where I focus is very much on how to then apply all the data being generated from these worlds and then operate and function with them through to end user experience. So as Paul mentioned, this golden thread, well, the golden thread's carried through data, obviously. And in essence, these points here are how do we take this flood of data that's coming into our built environment now and start to make use of it, start to render it both real time and longer process in its considering, but really to typically stretched operational teams, how do we also apply just enough data to make these informed decisions without ending up, flooding those operations with millions of points of data that they just don't need to see or necessarily have row-to-row exposure of. This comes into, as Paul's mentioned, this much more holistic approach where we need all the schemas, the naming, the BIM models as a foundation to work with, but applying it to the end operation, that service component, getting into things like the scope 3 emissions and I think what's really exciting is getting into that workplace viewpoint, starting to target experience, health, well-being, these kind of things that I guess all of us experience. So there's a lot of digitization and change in the sector generally at the moment. But what I think Scotland, to north to south of the country is really pioneering from the work I'm involved in, both at a UK national level, but also European and internationally, is taking all this rich data, but actualizing it, putting it into that end user experience, starting to increase workplace experience, and things like the pandemic have obviously forced our hand on a lot of that. But I think what Scotland's done with some of the work that the CSIC's certainly been leading is looking at, again, how do we take all of this and start to apply it to more value, both environmental, sustainable, but also societal. So that kind of walks into then something that if we can understand the built environment, if we can understand how to operate it, we can then start to take these smart buildings into much more user-centric positions. And the slide you can see here touches on some of the European definitions of what a smart building can be. And in a lot of ways, I guess for the majority of us, if we're not operating a building, we're very much focused on the time we spend in it, and therefore understanding BIM models, understanding naming conventions are actually completely irrelevant and non-required to the general user. But understanding that it's environmental, understanding my health and well-being and my safety is being taken care of, things like that are obviously how we associate with our places and spaces. So in this regard, I guess what the Centre for Digital Built Britain started to lay the foundations of, but I guess where Construction Scotland Innovation Centre and the Scottish Futures Trust are starting to pioneer and push out is how do we take all of that, apply it to our places and spaces to come up with these smart hospitals, smart schools, smart corporate real estate, whatever the end usage might look like. So that really, trying to sort of just touch on or summarize very, very quickly, because it's a short session today, is I think just reiterating what Paul said is really coming to this open and interoperable viewpoint. The technical maturity curve hasn't ended. In fact, it's probably only going to accelerate. So leaving ourselves not locked in to either methodology or technology is a future-proofing position. But when you start to bring that, it really enables this ability to flow in to the data-driven ops, starting to really look at that full end-to-end mechanism of the built environment and start to use our operations to drive these end user outcomes. And I think with all this data that we have these days, looking at things like carbon footprint, but whole life viewpoints of these things, it's a very exciting time to almost reimagine how we consider our places and spaces. And I think with things like IoT and real-time understanding, we now can measure how our places perform in ways that were previously probably cost prohibitive. And that's also giving our teams new and rich information to make, again, more informed decisions on how to move forward. So really, in conclusion, I think as we digitally transform our built environment, we also need to digitally transform our people, our process that goes alongside that across Europe, which is one of the most mature, if not the most mature continent on planet Earth in this smart capacity, has currently 1% adoption. The technology's there, but the people and process aren't really there to embrace it. So we need to join up some of those dots. I think the technology can then layer into this. And I think it presents a whole new way for us to collaborate and work with in our ecosystems in the sector to deliver, as I say, altogether new value and new ways of experiencing this. The final thing I'd like to say is just if there's more information in this more broader objective and what's happening at a Scottish national level, then contact CSIC, and there's some really exciting projects ongoing, and I think it's upon all of us to get involved and to create the future we want to live in. So thanks everyone for the time. I'm going to hopefully stop my screen and pass it back to Sarah.
Hi, that was fantastic. Thanks so much, Gordon and Paul. Slight change of background for me because I had to plug in my PC. I think what struck me there, if you don't come from a particularly digital tech background, is the simplification of data use and the end user experience. You know, we do need to get all of these systems to talk to each other, but it's about making people's lives easier. And like you say, it's about using the technology to make better data-driven decisions. We do have a digital department within CSIC, so like Gordon mentioned, if you want to get in touch to find out about any other of the projects, or indeed you would like to adopt any digital technologies, get in touch with us and we can let you know what other SMEs are doing and how it's making their business more productive. Thanks very much. I'd like to introduce our next speaker, Stuart Little from IRT Surveys. IRT provides unique images of energy, helping clients see energy loss and defects simultaneously, which enables an optimised refurbishment offering. Stuart has overseen the growth of IRT and helped ensure that they remain forefront of emerging technologies, be it drones, software or hardware. So looking forward to your presentation, Stuart. Thanks.
Thank you very much. Thanks, Sarah. I do love it when the people that go before me say things like data-driven decisions and the power of data and driving decisions and golden thread. That's the perfect introduction to exactly what we do. Can you guys see my screen okay just now?
Yep.
Are you looking at a great big picture of me or a lovely picture of the Scottish Parliament?
Scottish Parliament.
That's the question. Good, good. I'm looking at everything here. So IRT are 20 years old, and we're kind of well known for doing two things. We do thermal imaging and we do net zero software. So I'll just explain what you're looking at on screen at the moment. That's a picture of the Scottish Parliament. What the cameras do is have a quick look around them and say, look, the hottest thing I can see is maybe 32 degrees. It's the people sitting in the bus shelter at the front. I'll make that white. The coldest thing I can see is the night sky. It's -40. I'll make it black. And it basically divides the visible spectrum across that temperature span and paints the various colours, the various temperatures with a different colour. So white's hot, and blue and purple tend to get cooler and cooler. So it's a really good snapshot of visualising energy loss at a specific moment in time. So if you bear that in mind, I'll walk you through what we do with those images. So our mission is kind of grown, the company's changed and grown as the market has matured. So our mission at the moment is identify houses that need to be fixed, plan what needs to be done in a data-driven, solution agnostic manner, fund that retrofit. We've got access to over £7 billion to actually fund it, and then work with supply chain partners to actually implement the retrofits themselves. Most of our clients, because the market is so fluid, the funding landscape's fluid, the things like SAP keep changing, eco keeps changing, more products come onto market. People generally get into this analysis paralysis mindset that they're so confused they end up not doing anything. So we're trying to solve that by using a data-driven, pragmatic approach to simplify the whole net zero journey and make it affordable. And thermal imaging fits into that, which I'll explain in a second. So I'm a very simple person. I like to talk in small, easy words where I possibly can. But if you imagine buildings as leaky buckets and energy as the water going into the bucket, there's very little point in sticking your finger in one hole in the bucket, because you literally just increase the pressure on the other holes and energy just flows out the other ones. So we're very much into a fabric first approach. Do everything you possibly can, and then introduce renewable energy into the solution. The point of data, you can be an optimist and say the glass is half full, you can be pessimistic and say the glass is half empty, but if you analyse the data, you learn that the glass is actually twice as big as it needs to be. Now that's a wee bit, in an audience when you're actually live in front of people, you sometimes get a wee giggle at this point, but it's very true. It's about making sure you understand the problem and you design the solution to actually fit and meet the needs of the project. So we've been doing thermal imaging since 2002. We started doing software development in 2006. We launched various bits of software in 2009, 2012. About 2017, we brought out a platform called DREAM, that is the Dynamic Retrofit Energy and Asset Management Platform. And as the previous speaker said, you do need dynamic information. You need ongoing consumption data to make meaningful decisions. But in our view, the whole net zero is a journey, and the point of any journey is working out where you are today is vital. You can't start the journey unless you understand where you are. So let's get your data into shape, agree a destination, and then optimize the route exactly the way SatNav works in your car. So we have written this DREAM software that basically pulls in all sorts of data from your asset register, from the EPC register, from the Royal Mail, from Google, puts all in one place, aggregates it, sanity checks it, and then creates an individual roadmap for each individual house within your portfolio. So if you're, I don't know, Inverness Council, for instance, you can put the entire city of Inverness into this platform, and you can then say, look, just show me people living in fuel poverty areas, the areas of deprivation, show me people on the gas grid network or out with the gas grid network, and literally draw a polygon around it and create a group, and then say, well, that's our target. This is the step one of how we get to net zero. And we can then analyze that subset and tell you which houses qualify for grant funding and help you leverage as much funding as is possible. Thermal imaging comes into play, kind of, to my mind, quite critically at this point, because no one's data is accurate at the moment. Again, it was, I did smile, Gordon, when you said Europe's the most advanced, but we're only about 1% into the journey. Of that 1%, I wonder how good their data is, because it's very much in its infancy. Thermal imaging is a really good way to say, look, the data says that house is perfect. The cavities have been insulated 5 years ago. Is it really there? And that thermal image on your screen now, if you can see it okay, shows you that the green bits are well insulated and the red bits are missing. So this is when I'm talking about agreeing where you're starting from. That's a vital step to say, let's just verify the data. Let's sanity check the whole thing and establish where we truly are in terms of the building fabric performance. If you assume that that cavity is full and you install an air source heat pump, you will never get the return on investment and the savings that you hope you're going to leverage from that hardware unless the building's properly sorted. 2006, we wrote software that can literally turn pixels into pounds. So we can show you an after refurb on the left, before on the right, and then engage with the actual tenant or the homeowner to say, if you do this retrofit, there's the money, the carbon and the kilowatts you'll save. £347, 3.6 tonnes of carbon, 18,000 kilowatts. Look how good your neighbour's house is. That I think my teenagers would call it that FOMO, the fear of missing out, is a really compelling thing for people. They like to know that they're at least keeping up with the Joneses. So we have drones in the sky doing high-rise buildings. We're working with various partners on Google Streets style vehicles that can drive around the street electrically, in EVs, and gather LiDAR data, like the video right at the very start. That vehicle on your screen's got 2 LiDAR detectors on the roof rack. It's got 4 thermal cameras. It's got 2 hyperspectral cameras. It's got air pollution, noise pollution. It drives at 30 miles an hour and maps the built environment. The screenshot behind the background to that slide, my business partner is the guy that wrote Grand Theft Auto, a guy called Dave Jones, Scottish company. They raised £112 million and mapped every building in Europe, America, Canada, Japan, and the UAE in 3D. So what we've done in that 3D world is render buildings with their energy performance, then embed net zero roadmaps into each map. And you can actually download it and use it as a sat nav, and we can make your phone vibrate if you drive past the house that qualifies for funding. So it's a very cool, easy, cheap way to engage the general public in the need for net zero. Drones, maybe not super needed in Inverness. We're not things, a lot of buildings aren't above 4 or 5 stories, but if you've got buildings that are 15, 16 stories, drones are a fantastic way to do that, and superb, easy way to do big flat roof surveys. Quick case study of what's actually out there right now. We're in Aberdeen, live on a project where we put 22,000 houses into DREAM. We created a little consortium. We got funding from Bays. We selected about 4 lots of 500 that needed retrofitting, that met Bays funding criteria. They were EIS failures. We then engaged with the tenants. We thermal imaged them. About 150 people said, yes, please, I really want a retrofit. And we did various surveys to assess what would be right for each individual house. This little screenshot's mainly for people who are from south of the border, in case they don't know where Aberdeen is, but that's basically £5.5 million project. Half of that funding came from private equity. So there is plenty money out there to physically fund these projects, but the money at scale, capital at scale, needs a robust and mature market to deploy it at scale. And that's what we're working on. We're trying to say that we've got the tech and the software to join up the need with the funders and put it all in a dynamic platform that's nice and easy. So I think this is toward the end now, you'll be pleased to know. We basically put data in the top of the funnel into DREAM. Then we do a funding analysis. Once we've cleansed all the data and mapped it and modeled it, we then put it through how much money can you get for free, what grant and funding is available to help. And that varies from Scotland to England to Wales to Northern Ireland. Then we parcel that up and do a financial risk assessment on it to work out, can we bring private equity to it? Is it big enough? Because ideally we're looking for projects that are greater than sort of 5 to 10 million, really, to make the money affordable. Then we thermal image them. Then we've got a supply chain of contractors who can physically do the works. And then we thermal image again at the end, just to bookend the retrofit and make sure the job is done properly. So you get this nice visual audit trail. It's nice and simple, it's engaging, it's compelling. And we just keep doing it again and again until we hit net zero. That is the plan. That's my last slide. Thank you very much. Did I get you back on schedule, Sarah?
That's a few times I've heard you speak, and every time you do, I'm just amazed at the amount of tech and the way it weaves together the finance, because of course if you're thinking about retrofit, that's what you need to think about. People are worried about the funding, but it's just a fantastic example of digital tech being used to solve really big problems like net zero. And actually I might have a project in mind, so I'll pick up with you later. So that's all of our speakers. Thanks everybody for listening. We've got 10 minutes left for questions. And I've got one here from Alan, and it says, how do changes in the site installation from the original design get transferred into Dr. Livingston's toolkit? So I think that's one for you, Matt. Don't know if you want to come in quickly, and I've got a question for all the panelists after that.
Yeah, no, sure. Let me try and answer that. So I'll explain. So the process with the FETIS project that I showed, we did in analog sort of style, if you like. So my colleague Bartosz Belch when we found that there were services running through, we had to extend the cantilever of the modules from 1 meter to 2.5 meters. He then had to do a series of calculations on individual panels, hand calcs on the interfaces between them, and a whole host of work to validate the updated sort of structural approach. With the toolkit that Bartosz and Andrew are developing now, that would be able to be done in much more sort of real time, and with the optimization that comes from that, the system effect that you get from it all sort of meshing. So in the future, what that would look like, rather than a whole heap of work to be done to get to that point, much more dynamic, and that therefore allows us to respond really in a really agile and very financially and carbon efficient way to evolving opportunities. Or if we spot an opportunity to do something, it means we can really sort of take it through its paces very, very quickly. So hope that answers sufficiently the question.
Thanks. Yes, it does. So I've got a bit of a question for the panelists. We're obviously talking a lot about data and digital tools. There are a lot of buildings that exist that we're going to have to do something about in terms of net zero and retrofit, where no data at all exists, no drawings, no materials, nothing. How are we going to tackle those kinds of problems where actually we have a large number of commercial buildings where literally we don't have anything?
I'll be rude and jump in there, Sarah, if that's okay. I mean, we've got tools that can do rough desktop analysis. You know, we've got like dynamic elastic templates where you can say, this is a school built in 1976 in Essex, and we can pick up weather data and typical construction types of 1976. But ultimately, you have to visit site. Someone has to go and put boots on the ground and gather hard data. And then you can deploy all the IoT stuff and get meaningful ongoing analysis. But I think there's a big role to be played for surveyors, like retrofit coordinators, retrofit assessors, and go and gather meaningful data.
Agree, Stuart. What we do is typically run a gap analysis. And so you say there's no data, chances are there is some data out there somewhere, but it's probably old school and, you know, either on a USB drive if they're lucky, or on an old CD, or O&M manuals in some, that's it, lost, yes. And so it's taken out. But before, I'd start with the question, what are they trying to achieve? So if you say, you know, we need data to do what? And so the gap analysis starts with, what are you trying to achieve? Is it net zero? Is it maintenance backlog? Understand what the requirements, the outcomes are, and then work backwards from there. And then you can apply and look for the right data rather than say, we're looking for data. Get the right data and make sure that data, whether it be static or active, you know, is the right data to achieve those outcomes. So in short, starts with the gap analysis. Totally agree, Stuart. You need boots on the ground. Somebody's got to go and do the grunt work.
Mm. Yeah, and if I might jump in on that, so and what would be great is, you know, once that data is captured, you know, we're evolving now retrofit solutions. You know, we've done a lot of our work in the past has been new build, but retrofit's such a key requirement if we're going to overcome the scale of staggering scale of challenge that we have in front of us. So the near home solutions very much designed to be able to be deployed as a box within a box. So actually, it, you know, can be independent of the existing building, which, you know, frees up some of the constraints that would come from trying to retrofit an existing building, whether it be, you know, historic and the constraints around, you know, the preservation of the original building, or if it's just, you know, the fact that if it can be deployed as an independent system, then it can also be reconfigured in the future and remobilized in the future. So that has that circular approach. For our own factory in Invergordon, we've got an old 1980s industrial building. We're looking to do that same type of approach, but on steroids, where it's, you know, 18-meter clear span, you know, create an insulated, controlled environment within an existing shell. And great to do zero carbon new build school system, but we're doing a scholar school retrofit solution where actually, back in the 1960s, we were designing and building schools on a systemized approach, albeit it had asbestos and single glazing. If we can now go back in and actually there's really good data on that build system because it was a replicable build system, we can then sort of switch out some of those fabric elements with healthy biogenic carbon positive build solutions. So yeah, exciting prospects for that.
Those solutions do exist. I'll take that back to the project team. And this is a final question for Stuart. Thanks, Mohammed. After surveying buildings using IR, do you to the level of building fabric details? How do you retrofit them, or do you pass it to further surveyors to go to more details before suggesting the best way to retrofit the building?
So you cut out just in the middle there, Sarah, at
Yeah,
my end. I
right.
don't know what happened to everyone, but
So after surveying buildings using your tech, do you go further to the level of the building fabric details? And how do you retrofit them, or do you pass it to further surveyors to go into those details before suggesting the best way to retrofit?
we do desktop analysis for 90 pence a house. Then we do thermal imaging at £22 an elevation. But then inevitably, if you're going to do a retrofit, you have to get a retrofit assessment. We do full-on internal, external, daytime, nighttime thermal images at about £800 a house. We do air pressure testing. We've got little devices called G-skins. Probably the guys on the call have heard of these before. It's from a Swedish, not Swedish company, a Swiss company called Greenteg. But a G-skin's a little thermocouple. It's about the size of a stamp, and it's attached by a tiny little thin wire to something about the size of a box of matches. And you stick it on the wall, and it works out the actual U value of the fabric.
Oh.
And we take the actual U value, we import that into our model, then we can work out the U value of every single pixel on the fabric. So it depends on budget and time and everything else, but we can do occupancy assessments, retrofit coordination. We do the whole thing, but it all boils down to budget. And it's like Paul said, if the data goes in the top of the funnel, okay, but you can't afford to do that because all of that costs about £1,500 a house. There's 27 million houses. That's a heck of a budget. So let's just not go crazy. Let's filter it and then do it in little bite-sized chunks. Yeah. Eat the elephant slice by slice, Sarah. That's what they say, isn't it?
Okay, well, that's us coming to the last few minutes of the webinar. Thanks so much to the speakers. It's been brilliant. We've got some internet in the chat section for you to sign up to the web portals. All of the information for all the companies that presented today. Also, your feedback is really important. We're going to send out a wee survey, so if you can let us know what you thought of today, we'd really appreciate it. And yeah, thanks very much, and I look forward to seeing you at the next webinar. Thank you.
Thank you, Sarah.
Thanks, guys.
Thanks, Sarah.
Cheers.